Hello, welcome to CAD CAM demonstration number 3. My name is Solar. Let's get started. So today I'm gonna CAD CAM a simple part for one of the we do assignments. This one is still in the prototype stage, but I'm gonna quickly CAD CAM through this. Today I'm gonna be CAD CAMing in Inventor, and I will be doing some simulation with the vise. Let's get started. So I'm gonna start a sketch. So the part is 30 by 30. I'm starting a sketch with W, same as in Fusion, and then made a centered rectangle, and then dimension with D, or dimension up here. I'm gonna make a slot, you would call it, in the middle, center to center. It's going to be center in the center of a rectangle, and then out here. It is 8 in length, and then 6.8 in width, like so. I'm going to make a point in the middle, or I'm sorry, in the middle of the slot, rather. I'm gonna project some origin, so make it to construction, make another point right here. I'm gonna use mirror, that's key Y for me. Pick the point, pick center, I think I did that wrong. Point, pick center, okay, and then it's 20 in between. Doing it with mirror this way, the points will be mirrored very easily like that. That's okay. I believe that is it. I'm gonna finish sketch. I'm gonna extrude downwards everything, 4 millimeters in thickness. Then in Inventor I need to share the sketch. You do not need to do this in Fusion, but in Inventor, to get the sketch to be able to use it for another extrude, I need to share it. 8 millimeters, like so. I'm gonna make a new sketch, and then I'm gonna project the point. Add this point here. Oh, I'm sorry, not there, right here, I think. May need to see here, do this, project, yeah, like that. I just made the solid body invisible, like so. Finish. I'm gonna start with the side holes, so hole. I'm gonna pick this one, and I want an M4 clearance hole, so I'm gonna pick this one, countersunk, isometrisk. Let's see here. This one, it's an M4, and I'm gonna do close, I believe. Maybe do normal. Through. I'm gonna decrease this a slight bit, I think. 9.5. Okay, and then I'm gonna do another hole. Pick this one. And so this one is an M6. So threaded, countersunk, isometrisk, M6 through. And I'm gonna do 6.5 perhaps, or 6 maybe, like so. Make my sketch invisible. Then I'm gonna do some fillets, radius 5, like that. That's it. Okay, so we're gonna move on, make our cam. So I have saved these with already set up biases. So I'm gonna use two setup like this. I'm gonna make the top one invisible. I'm gonna place down my part real quick, like so. I typically place part in origin. That's the way I do it. And so when I do that, the part is static, so I cannot move it. It doesn't really matter where in space the part is, of course. It's just that the idea is that way I don't accidentally move the part. The idea is that we cam around the part, of course. The next vise is going to be upside down relative to this one. And so, of course, you could make one of these static if you wanted to. You could grind this, same as in Fusion, and they would be static. But my idea is that it just makes sense to have the part in center and then you move everything around the part. So it just easiest that way, I think. And it makes it easier also when you're placing down stuff. This is not as big of a deal, I think, in Fusion. But for example, so I'm gonna place down some stock. So I have saved again here presets of stock. When I place this down, now I don't need to constrain relative to this or anything. I can just constrain relative to the origin, because everything is in relation to origin, not to some specific part, you know. So I think it's simpler that way. So I'm going to constrain this for starters. So constrain, Control Shift C for me, constrain up here. So mate, pi. Then I'm gonna do flush, like so. I'm gonna do 1 millimeter, perhaps, offset, so that's 1 millimeter off the top. And so this way, I think, is honestly easier than using, a lot of the time, than using the built-in cam one. Obviously, if I'm just quickly doing something, certainly for the wood router, the Raptor machine, I just use the cam built-in one. It's just so much quicker, obviously. But for stuff like this, I always do this, even like in all cases, because now I can just constrain this to this. I don't need to offset this from the part by how much the stock is, you know what I mean? But by this imaginary stock cube from the cam, you know. Yeah. So just gonna go into this. I'm gonna do 40 by 40 by 30 maybe, let's say. Finish. So updates automatically. That looks good. A little much maybe. Oops. Doesn't really matter. It's too little, I think. So then I'm gonna constrain. So this, that. Like so. I have the vise centered by default, so that's done. Okay, I'm gonna set up my cam. So cam setup. I want for the Haas, milling, CX, Z, X, stock box points. I'm gonna skip that for now. Model this, fixture. Can select all these parts, and so it will warn on a collision. Wait. Yes. Then or actually first I'm gonna flip Z, flip X, and then stock box point, or yes, I'm gonna wait a little bit more. So stock from solid, this one, and then I can do stock box point, this one. Okay, post process 1010. I'm gonna do op1. It's called TCSM1-004. A trick I use often is save as user default in this case. So then with the next setup, if I do another setup, it will be already populated. So that's sort of, and then I just change it. And then for the next I just, so I have that as a recurring temporary one. So it's a good tip. Save some time, because it's like to write it out every time sucks. Okay, that's good. Yeah, I'm gonna set up next, I think, right away, so it's done. So I'm gonna make this invisible. Op2. I'm gonna change my what's it called? My jaws. I'm gonna change my jaws because these are the stepped, and so that will not work. So jaws standard. I'm gonna flip Z. I'm gonna constrain. Oops, that's what I wanted. I think you can notice that I've done this particular step a lot of times, so I can do that one pretty quick. Then we will see, we can start with this one, see if that will work. And then I have static definitions for all the parallels, so let's try 43. What is it? 41. So that will be pretty damn close. I think that's as close as it gets. Yeah, so I think I'm gonna be happy with that. Like so. That's done. Bring back the stock. But obviously I'm gripping on the part right now. Go back to CAM. Make another setup. So ZX, ZX, flip Z, flip X, model. Sometimes this one is a little difficult. In Inventor, if I can't get it, I will just go to modeling section here. Go to the part, solid bodies, and pick the part. Come back, fixture, like so. Stock, once again from solid, like that. 1020, up 2. And then I will do a model box point. This one will be fine. Okay. Obviously in Inventor you cannot do continuous machining, and so this is just obviously this stock describes that is still stock right here, and so that will be invalid. I will show some tricks to get the simulation working in Inventor, but ultimately this is all you need. In the cases that I've needed more, I've just modeled the stock, like I drive the part and then I just extrude what it is stock, basically, you know, if I really needed it, but this is fine. So we're gonna go back to op1, like that. Oh, whoops. so. Okay, Shift D to change the default. You can see how the same in the Fusion, maybe, I'm not sure, but you can see how the check mark moves, and that changes if I press face which one it will go to, you know what I mean? So this is, let's just say it's aluminum, I think. So let's see here. Shell mills, base mill, press OK. Actually, I'm doing this wrong, I realize. Create from templates. So I have these templates with pre-finished operations. So I'm going to press select this one. Then I'm actually going to do create from templates dormer 5 flute shoulder. So I'm going to pick this one, and so that's going to remove most of it. Then I'm going to come back with adaptive with a 10 mil, I think. 10 mil 2 flutes. That's just going to pick up the shoulder mill is quite rough, so it's going to pick up what it might have missed. Ensure this all the way down. And do negative 0.1. Like so. I think this one might have that. It's the same. Okay, generate. Let's see what we got. Typically when I simulate I do for operation. I think even in Fusion it will default to like all toolpath or toolpath after or something. I think that's just ridiculous. I only want the toolpath for the particular tool that's active. Obviously, I think that's very, very obvious. But whatever, because otherwise you get so many like lines. Yeah, so it's going to remove most of it. That looks pretty okay, I think. Okay, I think I will probably well, yes, I will finish. So let's try a horizontal, just for the fun of it. Let's do tool, end mills. Let's do 10 mil 3 flute, I think. But I want this 2. So you see this is a long one and this is a short one. I want a short one. The shorter the better, always. I'm gonna try that. Actually, I do want that, that's true. This little trick will make it so that I won't really finish this. I think it might go on top of here as well. I just do like a 1/10 below, so it will avoid it. And then selection, I will just select this. Strange. Okay, it looks okay. Good enough. I will do to the contour, same tool, this one and this one. This is not the ideal way, this is just the quickest way, let's say. Quick enough. In fact, I almost wonder. Not quite. Okay. That's pretty okay. Yeah, as I said, quick way, not the best way. Good enough. I will do the holes. So in Inventor I have a template, so create from template, and so I want a drill tab sequence, create all, and so it just creates a bunch of for me, and I just pick what I want. So spot drill, I want this hole right here. That's okay. Drill, I want this hole. So I will pick drill 5mm, drill special 5mm. This is the hole. Important to change model top, model bottom, drill tip through. I will use probably just drilling, wrap it out on this. Press OK. Counterbore. And this is why I like to model the chamfer, because I can just pick that and it's done. And then tap, tool, thread tools. I would like a spiral, probably a spiral point in this case. Maybe I will drill all the way through. Oh, that's true. Okay, maybe do it that way. I will probably change this then in that case to stock bottom, like so. So spot drill, drill, countersink, tap. That looks pretty okay. Then I will do another, but this time just a drill sequence, create all. I will see if I can include a spot in this. I will change to hole top -1. Yeah, so you see that that works. If I do model, it will be same for all, but if I do hole, it can be different. I do need to change the hole that I picked, however, here, so that works better. Okay, then I will just have a drill tool. I think I said 5mm, 4.5. I always have select same on diameter, so I don't have to pick both. That can be, there are a couple of those that are a little bit dangerous. That's like with really big things, sometimes you can miss that it actually did a hole somewhere far away and you didn't notice, so you have to be a little careful for sure. Okay, so it's pretty much finished. I will just skip to the end. Looks pretty okay. I think it didn't take quite everything here. Yeah, so I will probably use a bigger. Try this one. That should be good. Okay. That's really close to hitting, but that's good, I think. Yeah, so that should be good. But it's really nice. I can simulate this way, and I can be really sure that it's not going to crash. If it would crash, it would be a red sign in the bar here. I have noticed sometimes it can be, but yeah, it's never really hasn't really betrayed me yet, at least. I can show part comparison and check if I missed anything, but this looks good. Okay, so we can move on. Op 2. So for this, just a face. So Shift D to change. And then we do create from template, phrase dormer. Control G to generate. And then that's pretty much it. I might just deburr this by hand. And so I can check that this is okay. And so as I mentioned, there is a trick if you at least want to simulate of how it will look. So there's two tricks. The first and the trick that I use the most, that's not the nicest but it works, is that in Inventor you can simulate all if you would like. So think like this, and so now I simulate all. And so now I can look through the whole thing. So we'll do all this and then we'll go to the underside. The thing that doesn't work very well with this trick is that it uses the collision from the first setup. And so now it thinks that it crashes here because it's crashing into the first op wise, which doesn't exist on the second op, obviously. And so it doesn't work great. Another trick is that I can simulate this and I can go all the way to the end like that. And so I can right click and I can do stock, save stock. And I will save the stock to the desktop like so. Close. And then I can simulate up to, and I can do stock load stock. That. And so voila, you have the simulation basically, and it will show if it will crash or not, and you can see the final part. So it's a pretty okay workaround and works for most cases. In those cases that you need really high precision of the stock, what you can do is that if you save the stock, you can import that as a model and use that. The issue is that Inventor is very bad with meshes, and so I found that to be quite hard to get to work sometimes, so I don't do that anymore. But this can work pretty well. So that's good. That's okay. And then the last thing I will do is I will check the feeds and speeds. I think these are pretty good, but that's what I will check. And then once that's done, I will post. So I will post this one first. Process, Fabula Workshop. And I'll do all default, post. And that's it. Thank you for watching.